Hello everyone, my name is Parwin Etman, and together with my colleagues, we conducted a systematic mapping study on AI integration in CI/CD pipelines, and today I will share our findings in a clear and structured way. This is the roadmap of my talk. First, we have the motivation and problem. Second, our objectives and methods. Third, the finding and challenges, and then future directions and conclusion. The CI/CD pipelines are the backbone of modern DevOps, enabling continuous integration, testing, and deployment, but they face major challenges such as frequent failures, long test cycles, and delayed feedback. These issues slow down software delivery, and AI offers clear solutions. It can predict failures, optimize tests, and automate routine tasks. Together, these improvements make the delivery faster and more reliable. Despite this potential, the existing literature on AI in CI/CD pipelines is fragmented and scattered. There is no comprehensive overview on how AI is applied across different pipeline stages. This gap motivates us to conduct a structured and systematic mapping study. Our contributions are 5. A systematic mapping of 30 papers between 2018 and 2024, a taxonomy of AI uses across testing, build, deployment, and also monitoring, an inventory of tools and frameworks, and also analysis of trends and methods. And finally, we have a proposal of gaps and future research. We followed clear mapping steps. We defined our questions, searched the database, select the relevant studies, and then we classified and extract data. And finally, we synthesized the results. This process gave us clarity, consistency, and transparency. In our study, we asked 6 key questions. What are the main publication channels? How have trends been evolved over time? In which areas is AI integrated into CI/CDs? What are the research methods are being used? And what techniques are applied? And finally, what are the main gaps and future directions? We found that conference dominates with about 70% of publication, while journals makes up about 30%. This shows 2 things. First, the field is fast-moving, and researchers prefer conference for quick feedback. Second, the lower share of journals papers means that the area is young and still developing. We also looked at how publication evolved over time from 2018 to 2024. The overall trend is upward, showing a clear peak in 2021 with 7 conference paper and 1 journal article. This was the most active year. After 2021, the number of papers decreased slightly but remained constant. This figure shows where AI have been integrated in CI/CD pipelines. The most common area is test cases with more than 15 studies. This makes sense because AI execution is costly and time-consuming, and AI can help decide which tests to run first. The second main area is build failure predictions, followed by bug detection and static analysis. These critical points in the pipelines where early prediction saves time and resources. But what is more interesting is the underexplored areas such as deployment and rollbacks, monitoring and anomaly detection, and finally DevSecOps and security. This chart shows the type of research conducted in the area of AI for CI/CD pipelines. The vast majority are experimental studies, about 70%, about 77%. This means most researchers are testing AI models directly on data, often controlled setups. We see only a small share of case studies and theoretical contributions, each about 10%. Even fewer are service studies, only around 3%. We observed a wide range of AI techniques, like machine learning methods, like the SVMs, random forest for build failures prediction, deep learning, especially CNNs and LSTMs for bug detection and log analysis, reinforced learning for adaptive tests, for adaptive tests, and then NLP for commit messages and bug reports. And then we have the search-based optimization, such as the genetic algorithm. And finally, we have the hybrid and ensemble methods, combining strengths of multiple models. This diversity shows both creative and fragmentations. We identified key challenges like the lack of benchmark datasets, limited explainability of models, weak integration with CI/CD tools, and over-reliance on static datasets without real-time learning. And also the minimal human-in-the-loop design. These gaps hinder adoption in practice. Looking ahead, we have 6 key directions for future research. First, building public benchmark datasets to allow fair comparisons. Second, the improving explainable AI, so models are more transparent and trusted. Third, exploring large language models in CI/CDs, especially for analyzing logs and code. Fourth, we have the development of a real-time adaptive system that learn continuously. And fifth, we have the strengthening DevSecOps and AI-assisted security. And finally, promoting human-AI collaboration, combining automation with human judgment. And to conclude, our study shows that AI holds strong promise for optimizing CI/CD pipelines. The main area where AI already proves valuable are the test cases, failure prediction, and automation. However, the field is still at an early stage. Research is fragmented and dominated by experimental studies, with limited diversity in methods and application. Our systematic mapping provides a structured foundation. It organizes existing knowledge, highlights gaps, and points to where future researchers should focus. Most importantly, to realize the full potential of AI-driven CI/CD, we need a closer collaboration between the researchers and the practitioners. Together, they can transform experimental insight into a practical, scalable solution for the software industry. And thank you all for your attention.